Hi folks, in this video I want to keep looking at the Ramsey model, but in previous videos we looked at the deterministic version. Now I want to look at the stochastic version, the stochastic Ramsey model. And still looking at the social planners problem, although we know that's going to be identical to the decentralized problem. And I'm going to focus again on a specific example with specific parameter values. So again, full depreciation, log utility, and Cobb-Douglas production. But now production has this extra term in front of it, TFP, and Z is going to be stochastic. In particular, Z is going to be an AR1 process, so the next period's value of Z is going to be equal to rho, the persistence, times the current value of Z, plus some shock, epsilon prime. And epsilon prime, this is not so important, but you can think of it as being normally distributed with mean 0 and a variance sigma squared. So that's going to mean, for example, that the expectation of Z prime, our best estimate of tomorrow's value of TFP, given today's value, so conditional expectation, is just going to equal rho Z, rho times the current value. And our budget constraint is going to be the same as before. Consumption plus our choice of capital in the next period is going to equal output. Again, there's full depreciation here. So that's our budget constraint. Let's set up the Bellman equation. Now the Bellman equation here is pretty much the same as before, except now for the continuation value we have this expectation around it, this conditional expectation, because Z is stochastic. And we need our constraints here, of course, so this is subject to the budget constraint and to the exogenous process for TFP. Now, I'm going to make a guess for this value function. The guess is going to look like this. The value function is going to be a function of both the level of the capital stock and TFP. So there's two state variables now. And the functional form is going to be like this. So there's going to be a constant term, A. There's going to be a term that is proportional to the logarithm of capital, and a term that is proportional to TFP. Really, I guess this is the exponent of TFP. Now let's plug this guess for the value function into the Bellman equation. Let's take first order conditions and solve for these undetermined coefficients like normal. And you'll notice here I've just substituted out consumption from the budget constraint. And here in the expectation, the continuation value, the value function in the next period, we obviously have the next period's values of K and Z. So we can rewrite this. Obviously, A is just a constant, so we can take that out of the expectation. B and C are just constants. And in particular, K prime, although it's tomorrow's it's tomorrow's value of the state, it's chosen today, so we can also take that out of the expectation. So the only thing that remains in the expectation is this Z prime. And remember, we said earlier that the conditional expectation of Z prime, conditional on the current value of Z, is just rho Z. Okay. Okay, now we've got rid of the expectation, so we can take first order conditions with respect to our remaining control variable, k prime, and it appears twice here, here, and here. So our first order condition with respect to k prime is just minus 1 over this term in the parentheses plus beta b times 1 over k prime. And that's equal to 0. And if we rearrange, we get that k prime is going to be equal to beta b over 1 plus beta b times output. So we don't know what b is yet. We still need to determine that by plugging this back into the Bellman equation. Actually, before I do that, let me just give you the policy function with the undetermined coefficients for for C. And again, we have that consumption is also just a constant fraction of output, as we saw in the deterministic model. It's just now output is stochastic. Okay, now we're ready to plug the policy function that we found, given our value function, back into the Bellman equation. And if the two sides of the Bellman equation are equal, then we verified our guess. We know our functional form for V was correct. And in doing so, we can find the values for these coefficients, A, B, and C, that were previously undetermined. A, I'm not going to bother with just because it's a constant, so it doesn't really matter. And it's just very tedious to find. But B and C we can find very easily. And of course, I can get rid of the max function now. So I'm just plugging in directly the log of consumption here. Now plugging in the policy function for k prime, and then finally we have this extra term relating to z. So in this expression, we can see on both sides of this equation we have constant terms. We also have terms that are proportional to the logarithm of capital. So here, here, and here. So in order for this to hold with equality, these coefficients have to be equal on both sides. And likewise for z, we have these coefficients here. And again, this equation of the coefficients of z also must hold. So this is going to give us a system of two equations, one in B and one in C. And we can find B and C, these undetermined coefficients, by solving those equations. So let's do that. So firstly, our equation in B. On the left-hand side, we just have a B. On the right-hand side, we have an alpha plus alpha beta B. I'll write that like that. And of course, if we rearrange that, we just get alpha over 1 minus alpha beta, which, if you remember from the previous video on the deterministic Ramsey model, that was the same coefficient we found on the logarithm of k there. So really nothing has changed in that respect. Now let's solve the equation for C. So on the left-hand side, we have a C. We also have a 1 and a beta B and a beta C row. So we have both C and B here, but we've already found B. So we can rearrange this first to put all the C's on the left-hand side. It's beta B over 1 minus beta rho, and then we can sub in B here, and we get that C is equal to 1 over 1 minus alpha beta times 1 minus rho beta. So what have we found? Well, we found our true value function, and we've now verified our guess as a constant term. I haven't found that yet, but you can find that if you want. And then there's a term that is proportional to k, to log of k, and the coefficient of proportionality is alpha over 1 minus alpha beta. And then there's a term that is proportional to z, and the coefficient there is this. So this is our value function. We can also use B to plug into our policy functions and find the policy functions. And as you might expect, we get that the choice of capital tomorrow is just going to be a linear function of output. And again, the coefficient here, alpha beta, that's just the same as in the deterministic model. Likewise for consumption, our consumption policy function is exactly the same as it was before. Constant fraction of output. So that was just a quick example showing you how to solve the specific version of the stochastic Ramsey model. Thanks very much. I'll see you in the next video.